All right, hi folks, this is Larry Mussolino. I'm recording a video for Objective 3 here in Math022. And really in Objective 3, the main topic is solving different types of equations. So let's do a few examples, and we'll start off with some simpler equations and then work up to some more challenging ones. All right, so let's take a look here. So here's an equation, and let me remind you that the goal is to get the letter, in this case it happens to be y, all by itself on one side of the equation. All right, and in order to do that, we may need to cancel out different operations. So to cancel a multiplication, we can use the opposite of multiplying, which is division. To cancel a division, we can use the opposite, which is multiplication. And of course, to cancel an addition, we can use the opposite of addition, which is subtraction. And then to cancel a subtraction, we can use the opposite, which is addition. So let's do a couple of quick examples here. How about if I had x plus 7 equals 12? Well, remember, the goal is to get x by itself. In order to get x by itself on the left-hand side of this equation, we would have to cancel out or eliminate this addition of 7. But to cancel an addition, we want to use subtraction. So what that suggests is we should subtract 7. But there's a rule that says whatever operation you do to one side of an equation, you have to do the same to the other. Usually we write these directly below the equation. So adding 7 and subtracting 7 cancel each other out. That leaves me just an x on the left side, and on the right side, 12 subtract 7 is 5. Notice how we do have x all by itself. That's how we know we have the solution that we're after. I'll give you another example. How about 6x equals 18? Well, in this case, the 6 is actually multiplying the x. Even though there's no multiplication symbol, we can write it in ourselves. So 6x really means 6 multiplying x. Well, remember, we want to get x by itself, so we want to cancel out a multiplication. Well, to cancel out the multiplication by 6, we can use division by 6. We usually write it underneath using a fraction bar. But if I divide by 6 on the left side, I also have to divide by 6 on the right side. On the left side, multiplying by 6 divided by 6 cancels out, leaves me just x. And on the right side, 18 divided by 6 is 3. So the answer here is x equal 3. All right, let's go back to this example. I want to get this y by itself. Well, right now, y has an addition of 8 on the right-hand side. Well, I'd like to cancel out that addition of 8. The way you cancel out an addition is use subtraction. So I'm going to subtract 8 to get rid of that addition of 8. Whatever you do to one side, you have to do the same to the other. So adding 8 and subtracting 8 cancels out, leaves me just a y. On the left side, I have -3 subtract 8. -3 subtract 8 is -11. So that is the solution on this one. All right, let's do a few more examples. Let's come here to multiplying to get an equation, to solve an equation. All right, well, here's what we have on this one. It says -34 equals -x over 8. Now, when you have a negative sign in front of a fraction like this, you can either put the negative sign associated with the top, the numerator of the fraction, or the bottom of the fraction. It's up to you. So I can either write this equation like I just did, or I could write it like this, whoops, and put the negative sign on the bottom. It's up to me. I could write it either way. Well, I know I want to get x by itself, so it'd be better for me to write it this way. And now I have to analyze what needs to be done to get x by itself. Well, notice right now, x is being divided by -8. Well, to get rid of a division, we can use multiplication. By the way, whenever you see a fraction bar means division. So on the right-hand side, I want to cancel out that division by -8. Well, I know multiplying will do that. So I'm going to multiply by -8. But if I do that on one side, I have to do the same operation on the other side. On the right side, multiplying by -8, dividing by -8 cancels. That leaves me just x. And on the left-hand side, I could just do this multiplication. -8 times -34. Well, a negative times a negative is a positive, and 8 times 34 is 272. So the answer here is x equals 272. All right. Let's do an example with fractions in it. All right. Here's an example that is asking me to solve for x. So it has 3x equals 6/7. Well, I know I want to get this x by itself. Right now, x is being multiplied by 3. Well, to get rid of a multiplication, we use division. So I'm going to divide both sides by 3. On the left side, multiplying by 3, dividing by 3 cancels out. Now, on the right side, I'm going to think of this 3 as 3/1. The only reason I'm writing it that way is I want to be able to show that this is one fraction divided by another fraction. Well, to divide two fractions, what you do is you change to multiplication and flip the second fraction upside down. Well, I'm going to do that. I'm going to leave the top fraction as is. I'm going to change to multiplication, and I'm going to flip this bottom fraction upside down to make it a 1/3. All right, now I'm just going to multiply straight across. 6 times 1 is 6. 7 times 3 is 21. I'm not quite done yet because I'm noticing it says simplify your answer as much as possible. Well, that's asking me to try to simplify 6/21. Well, I'm noticing 3 can evenly divide top and bottom. So I'm going to divide the top and bottom by 3. That gets me 2/7. That's the final answer. All right, let's do a few more examples here. Let's do solving a two-step. All right. So what they'd like me to do here is solve this equation, which really means get v by itself on one side. All right, so here's the equation they're giving me. Well, I know I want to get this v by itself. To get started, I'm going to get rid of or cancel out this addition of 4. That means I'm going to subtract 4 from both sides. Adding 4, subtracting 4 cancels out, so I'm left with v/4 on the left side. On the right side, I have a -20 subtract 4. That's -24. All right, but I need another step because I don't have v all by itself yet. Right now, v is being divided by 4. Remember, this fraction bar is division. So to get rid of a division by 4, I'm going to multiply by 4. Got to do the same operation on both sides. Multiplying by 4, dividing by 4 cancels out. That leaves me a v by itself on the left-hand side. And on the right-hand side, a negative times a positive stays negative. And 24 times 4 is 96. So the answer here is v equals -96. Okay, so in this example, we did need 2 steps. We first had to get rid of that addition of 4. Then the second step was to get rid of that division by 4 in order to get v by itself. All right. How about, let's do one of these. All right. So now what we end up with is a variable or a letter on both sides of the equation. Well, the first step for these kinds of equations is get rid of these parentheses by using that distributive property. So let me take this 3 that's in front of the parenthesis here and multiply it inside the parentheses. All right, 3 times u is 3u, and 3 times 7 is 21. All right, now here's what we'd like to do. We want to get the variable, the letters, to one side of the equation and get the numbers, sometimes we call those the constants, over to the other side. So here's what I'm going to do. I'm going to get the u expressions over to the left-hand side. Now, if you wanted to get the u expressions over to the right-hand side, that's perfectly okay. It's up to you. I'm going to get it over to the left-hand side. Well, that means I want to get rid of this 3u from the right-hand side. Well, to cancel that out, I'll subtract 3u. But I have to do that to both sides of the equation. So adding 3u, subtracting 3u cancels out. 7u minus 3u, these are like terms. When I do that subtraction, I get 4u. All right, well, now I still want to get u by itself. Well, to do that, let me first get rid of the subtraction of 37. So I'm going to add 37 to both sides of the equation, because that'll cancel out this subtraction. That's going to leave me 4u equals, I think that's 16 on the right-hand side. All right, well, I just have one more step to go, because if I want to get u by itself, I've got to get rid of this multiplication by 4. To get rid of a multiplication, I'll use division. Multiplying by 4, dividing by 4 cancels out. I'm left that u equals 4. That is the solution on this one. All right, let's see if there's another example, maybe. Let me do this example here. This one's a little challenging. It says, solving an equation that has 0, 1, or infinitely many solutions. So let me discuss this a little bit. Let me go to the explanation here. Okay. So let me try to explain the 3 possibilities. These are the 3 possible outcomes when solving an equation. You could end up with one solution. You know, like the example we just did a second ago, we ended up with u equal 4. You could end up with no solutions. That will happen when, as you're solving the equation, you end up with a false equation like 10 equals 12. Well, 10 equals 12 is a false equation. That would tell you there's no solution. The other possibility is there could be infinitely many solutions. You'll know that if you end up with a true solution like 6 equals 6. Okay, so let's work these 2 examples and see what happens in each one of these scenarios. All right, let's do the first example. And to get started here, I'm going to get rid of parentheses by multiplying inside using the distributive property. So this 4 is going to multiply inside. That's going to be 4y plus 4. I'm going to copy down this plus y. On the right-hand side of the equation, this 5 multiplies the y, that's 5y. And this 5 multiplies the 1, that's minus 5 plus 9. All right, well now, before I do anything else, I'm going to combine like terms on either side, because if I can combine like terms, that will lead me to a simpler equation. Well, here's a 4y plus another y. When you add those together, it's really 4y plus 1y, so that's 5y. On the right-hand side, I could think of this as -5 plus 9, which is a +4. All right, well, I know I want to get the y expressions to one side. So I'm going to subtract 5y from the right-hand side. Of course, I have to do the same thing on the left-hand side. Well, notice what happens. This is kind of a strange thing happens. This 5y cancels out with the subtraction of 5y. This 5y on the left side, same thing, cancels out. I'm left with the equation 4 equals 4. So notice the variable y canceled out on both sides, and I'm left with a true equation because 4 equals 4 is true. Well, when that happens, we say there's an infinite number of solutions. Or you can say all real numbers are solutions. So this is our answer on this one. Okay, so again, what can happen when you're solving an equation like this is the variables might cancel out on both sides. And then you have to decide if you end up with a true equation like we did here, 4 equals 4, or you could end up with a false equation. And if I had ended up here with 4 equals 9, let's say, that would have been a false equation. Then that would say to me, there's no solution. All right, let's do this bottom equation here. It says 3u plus 2 plus 2u is 7u minus 1 plus 9. All right, first step, multiply inside the parentheses. 3 times u is 3u. 3 times 2 is 6. Copy down the plus 2u. On the right-hand side, the 7 multiplies the u, that's 7u. And the 7 multiplies the 1, that's 7. Again, I'm going to combine like terms on either side. On the left side, I'm seeing a 3u plus a 2u. Well, that's a 5u. On the right side, I have this -7 plus 9. That's a plus 2. All right, I'm gonna get the u's together on the right-hand side. Remember, it's up to me to either get the variable by itself on the left side or the right side. It's up to me to decide that. I'm going to subtract 5u from both sides here. That will cancel out. That's going to leave me 6 is 2u plus 2. I'm going to get rid of this addition of 2 by subtracting 2 from both sides. That leaves me 4 equals 2u. I want to get u by itself. Last step, divide both sides by 2. This multiplying by 2 cancels out the dividing by 2. I end up with u equal 2. But of course, that's one solution. So I'm going to check. I'm going to select this answer and put a 2 in this answer box for u equals 2. All right, folks, hope this is helpful as you're getting started here in the objective 3 with solving equations.